Just a transfer of pollen from the same anther to the same stigma of same flower. Okay, this within the same plant. It is called as an autogamy. There is another form of self-pollination. It is like a, can anyone tell? The same plant,
Wait,
different flowers. Gynetogamy. Okay.
monogamy, sir.
Yeah. Then what happens if it is self-pollinated? If it is cross-pollinated, we have discussed, but again we will discuss. Normally, self-fertilization actually favored constancy and fitness of the genotypes to the immediate environment. Okay, like during the evolution we have discussed, like recessive alleles got eliminated, the self-fertilizers now there the mutation rate is very less. The load of recessive mutations are very less. That's why they are uh, resistant to inbreeding depression. Means self-fertilization assures that the constancy means they will not segregate, and why it and ultimate fitness the to the environment which they are growing. Okay, that's why the self-pollinated crops actually evolved from cross-pollinated crops. Earlier all are cross-pollinated crops due to the during the adaptation mechanisms to the immediate environment, they evolved to the self-pollinated crops to increase its fitness uh, to the environment. Then it is also called as an autogamy, self-pollination. It's an extreme form of inbreeding. Selfing is an extreme form of inbreeding. There are other methods like inbreeding, submating, all the methods were there, but selfing is actually the extreme form. It perpetuates the parental genotypes from one generation to the next generation. Means if A is there, if it is self, A will sorry, A will be there. If it is a homozygous in the self-pollinated crops. If A is there, it will definitely segregate. And if you continue selfing, we already discussed, increases the homozygosity of the genotypes in the generations. And the rate at which the homozygosity attains in the generation, it's calculated by the formula. Everyone know this: 2 power m minus 1 divided by 2 power m whole to the power of n, where m is
Sir, it's wrong, I think, sir. Or it's correct, sir.
maybe typo error. What is the correct, you can tell?
No, sir, no,
Number
sir.
is number.
Correct, sir.
Number
Maybe
of self.
2 power m
Number of
minus
selfing
1.
and n is genes,
Yeah.
sir.
Yeah,
N
yes, sir.
is the
Yes, sir.
number of generations you are selfing and number of genes that are in heterozygous gene pair. For example, you have one gene is heterozygous, you're following 5 generations. What percent of homozygosity you are going to get? Calculate 2 power 32 minus 1 divided by 32. It's almost 90%, 89 to 90%. Okay. Like this, we are calculating the percent of homozygous individuals when we are doing a selfing in the generations. So basic points, and when this formula exactly fits, when we are assuming that there is no selection, we are doing selfing, but we are not doing any selection. If you do selection, what will happen?
Favorable alleles will get
For example,
enriched.
increases. For example, you are selecting for cap one type of trait, like it's having gone controlled by capital A, and some of the trait which having heterozygotes. If you are selecting only homozygotes, then the selective advantage for, mainly for homozygotes you are doing, then automatically the proportion of this genotype will be increases. If you are selecting small a, the proportion of this genotype will be increases. If you are doing selection for heterozygotes, then definitely there will be selective advantage for this genotype, then it will be increases. Then what is the relevance of this formula? Okay, this when you apply this formula only, you are assuming that you are not doing any selection during the generation in the breeding program. Understood this point?
Yes, sir.
Then, along with the selfing, the proportion of homozygous genotype, like for example, when there is a linkage between the trait, means linkage increases the proportion of homozygous genotypes for one or the other alleles of a linked gene, but that does not change the percentage of homozygous gene pairs, that is percent of homozygosity. What does it mean? Anybody have an idea? Means can share your opinion. It's easy. Please tell. Not understood this point. See what happens when there is a linkage. The two alleles of a gene, they will segregate together. There is no independent assortment. It may increases the homozygosity of the particular genes uh, of the particular genotypes. But proportion of homozygosity is like proportion of individual having homozygosity at all the loci, it will not account. Okay. Maybe linkage may some alleles they having some genes may they increase in the homozygosity. But you can't say the total percent of homozygosis throughout the population. It cannot be determined by, it is not affected by the linkage. Linkage at individual locus at between the genotypes, maybe at locus it increases the homozygosity, but whenever you take the percent of homozygosities in the population, it will not affect. Understood? Am I audible or not?
Sir, please repeat it again.
Yes, sir. Can you repeat it, sir?
For example, linkage increases proportion of homozygous genotypes. This point is clear. Linkage increases proportion of homozygous genotypes for what? One or the other allele which linked genes.
Sir, what if they are linked in repulsion phase, sir?
No, that will be the another. Yeah, that is another case. Then definitely there will be increase in the heterozygosis. That also possible. Yeah, if it is in coupling, assume that it is in coupling phase. Normally it increases the your homozygosity. If it is in repulsion phase, definitely they will maintain as heterozygotes. Okay, there is no like if A, sorry, even there in repulsion phase, yeah, that also possible. They not may increase that much homozygosity, but you think that they are in coupling phase. Means at some loci they will increase the homozygosity. But when you account, for example, if there is a population, the percentage of homozygosis it will not affected by the linkage. Means at some at different loci there may be heterozygosis. Those genes which are linked, they in that case only there will be increase in the homozygosity at particular loci. But when you taking the account of percent of homozygosis in the population, we have to consider the zygosity of the all the loci of the all the individuals. Okay, then that time the linkage will not affect the percentage of homozygous. But at loci, maybe it increases the homozygous genotype. Now you understood? At
Yes,
particular
sir.
loci, linkage maybe
Yes.
increases the homozygous individual, but when you're taking all the individuals at all the loci, it will not that much affect. Okay, this is the point. Then homozygosity at most loci does not mean homogeneity in the population. For example, you are getting an individual. In this individual, all the loci are in homozygous state. In this individual also, all the individuals are homozygous genotype, homozygous loci. It means that all the individuals having the loci having at all loci having homozygosity. It means that the population you can say that is homogeneous.
No, sir. They may have different alleles at
Yeah,
homozygous locus.
that's what. Okay, there will be difference. Even capital A, in another one there will be difference in the allelic combination. There will be a homozygous for different gene. Okay, that's why they may be homozygous but not be the homogeneous. So that point you should be remember. That's why whenever we are defining the genetic structure, we two words we are using at one locus and among the population: heterozygous, homogeneous, homozygous, homogeneous. Like this, there will be several classification. Okay, that thing you have to be considered while breeding for self-pollinated crops. Then, if you look at how selfing affects your the percent of homozygosities, when you take this is segregating at one loci. When you do selfing, what will happen? There will be 50% reduction in the
It
heterozygosities.
will
Heterozygous.
segregate.
Okay, sorry. Okay. Then 50% increase in the homozygosity. Capital A 25%, small a 25%. It's same for like again if it is not if selfing on this AA, it will not going to segregate 25% away. But if you self again this capital A small a, again it will segregate 12.5% AA, 25% capital A small a, 12.5% AA. Again it will be again reduction 1 by 2n. So 1 by 2 to the power of n. Okay, understood how selfing affects the percentage of homozygosis and what is the effect of linkage and the
Yes.
homogeneity and the homozygous at the loci. Understood these three concepts? Many times they will
Yes,
miss
sir.
these points and they will ask several questions. In ASRB, it is very important. Then, actually, the breeding for self-pollinated crops started with in 1843 when Lee Courtier was first time. He clearly indicated that the importance of selecting the individual plants. Like if you select the individual plant, which based on the character, and keep advancing them only, then he got some improvement in the progeny generations. He documented that. Then again, a scientist called as Louis de Vilmorin, the famous principle. Can anybody recall what is the famous principles of Louis de Vilmorin? Vilmorin isolation principle. Okay,
More in
in
isolation
France,
principle.
he actually given a single plant progeny selection. He selected, then he gone for progenies. Based on the progeny, he assessed the value of the parents. Okay, that is called as famous principle called as Vilmorin isolation principles. Then again, Nielsen's actually at Swedish Seed Associations, it is situated at Savalf. Actually, they also started like plant progeny test based on the principles of Vilmorin. Then again in 1903, we already know the Johansen given the pure line experiments. After that, the breeding slowly takes place. Like breeding for many in breeding methods are implemented in many crops. Now new varieties are developed. You'll discuss in detail. Then, what are the different phases of plant breeding? One is there are two different phases. One phase is exploitation of existing variation. Another phase is creation or creation of reservoir of required genetic variability. If the variation is existed in the population, we first do collection of all the variables like germplasm collection, whatever it may be. Then, if we introduce to desirable place, okay, then you do for acclimatization. Then you do either if it is not, it is a very new variety to the new place. Then you leave it for acclimatization. After acclimatization, do selection. Either if you are doing existed like already variability in that place existed, you directly go for selection. Either you can use pure line method or mass selection method. After attaining homogeneity and homozygosity, you evaluate and disseminate. This is the one phase. But in other phase, if there is no variation for the trait, you need to create the variation. How to create the variation? One method is through hybridization or through the induction of mutations or through manipulation of the ploidies. Either of these ways, we can create the mutation like a variation in the population. Then you select the created variation, better variation according to your purpose. Then you go through any method of breeding, pedigree, mass, bulk, or backcross. Then you develop a variety with a high uniformity. Then evaluate and dissemination of this variety. This is the two different phases we have already discussed, but just in a summary I have discussed again. Then what are the different breeding methods for self-pollinated crops? One is introduction is the oldest method, and mass selection is also oldest method, and pure line selection, pedigree breeding and bulk breeding, backcross breeding and multi-line varieties, mutation breeding, polyploid breeding, and population improvement for self-pollinated crops. Actually, many times it's repeated. Who given the population improvement in the self-pollinated crops? The Palmer scientist, he has given this concept. You can use the recurrent selection in self-pollinated also. He actually first explained that. Then hybrid breeding also we can in rice. Hybrid breeding is major relevant. We have discussed in detail. And marker
Sorghum.
selection is the only tool. It's not a breeding method. To improve the efficiency of this method, what are you asking?
Sir, I was saying sorghum too, sir.
Yeah.
Hybrid breed.
Yes, sorghum in many crops. Okay, in many crops is there. Just I take an example of rice. Okay. Then marker rested, but only to enhance the efficiency of these breeding methods, marker rested selections are used. Then genomic selection, and we can use genome editing and transgenic breeding. Okay. So there are a number of methods are available to improve the self-pointed crops. And majorly, if you want to study in detail, prefer Pundan Singh and BD Singh book for these methods. And for marker state, genomic selection, gene editing, all these methods you can refer AK Singh and